Okay, so hello everyone, this is Akshay here, and today I'm gonna solve this question that is a player eating bananas. And today marks our day 600, I don't know, 27 of our problem solving journey. And let us resume again with the today's question. So let us quickly switch back to our tab section and we will understand step by step what this question says and then we will solve it. So there's a player named Koko is given an array where each element represents a pile of bananas. So she has exactly k hours to eat all the bananas. So that's point number one. Each hour Koko can choose one pile and eat up to S bananas. So S पे कोई constraint नहीं है. That player can choose a random bananas, let's say S bananas, and the conditions here are if the pile has at least S bananas, she eats exactly S of those, and if the pile has fewer than S bananas, she eats the entire pile in that hour. If the pile has at least S, okay. So Coco can only eat from one pile per hour, and our task is to minimize the value of S, that is the banana per hour, such that the player can finish all the piles with K hours within K hours. Okay, K is given to us. So let us do a quick dragon. If the Coco eats at the rate of 5 bananas per hour, that means for this given array 5, 10, and 3. Uh, it will take if the s is equals to 5, then this to complete this pile it will take 1 hour. To complete this pile it will take 2 hours, because at each hour she is consuming 5 bananas, right? And to this one again in 1 hour, so 2 plus 3 plus 1, that is 4, and that's your given number of hours is 4, and that exactly matches to it, right? So in this video that and this question been asked in many great companies. In this video we're gonna do two approaches. That is method one, a brute force approach, that is try for all possible values of s such that this criteria meets, uh, that is she can eat within k hours or exactly k hours. Method two, an optimized one, right? And we will see how this code work, right? So first of all, what the brute force says ki uh, s she can choose any bananas which is pointing to s, right? So what is the range of s? I can say the range of s can go up to 1, that is the minimum banana she can choose to eat per hour, till the maximum value in this array, right? So if that is the case, then we need to run a for loop for this thing. And at every point, we need to check, let's say with a helper function, that this helper function will basically give key if it has an array as an parameter and one more variable, that is, let's say s, right? So it will give me a number in which uh, this helper function will tell me that how many hours were needed to complete this array of I, which has a pile of bananas, using this S banana. S is nothing but the number of bananas she can eat per hour, right? So here goes our method one. Method one is again a self-explanatory code, and if you'll see, you will be able to get it very quickly. So I have declared one variable that is high, and again I iterated in the for loop. Using the for loop, I iterated in the array, and I found the maximum of it. And then as a second step, using a for loop, I have iterated that is I equals to 1 to I less than equals to high, and calling a helper function. And at any point of time, that is using this ith banana, if I'm getting that the number of hours I need to complete all the piles that is present in this array of I, if that number of particular hours, which is getting from my helper function, it is less than equals to k, then and there I'll return I. Why I will not check for rest of the ith value? Because the question says you need to find the minimum number of bananas to form such combinations, right? तो हम i equals to 1 से शुरू कर रहे हैं, तो जैसे ही कोई पॉसिबल वैल्यू मिला हमें, लेट्स से 1 से लेकर के हम 10 तक गए, एंड 10 पे हमें आंसर मिल गया, राइट? तो देन एंड देयर वी विल रिटर्न, बिकॉज वी वांट मिनिमम. आई डोंट नीड टू चेक फॉर द वैल्यूज ग्रेटर देन दिस 10, right? Because I want the minimum answer. Hope that makes sense. And in this helper function, what is happening? Okay, so let us calculate one case. Let us run one case in which we understand that how this thing is working. So 5, 10, 15, and 20, right? And let's say the number of banana Coco is choosing is 10. 10, right? So S pointing to 10. So uh, that means at per hour, she can consume 10 banana, right? So it is 5 only. So number of hours required would be 1. And this, it is 10. So strictly 1. Now it is 15. So at the first hour, she will consume the first 10 bananas. And in the next hour, she will consume the next 5. So 2 hours, right? And here strictly 2 hours. So total value you will get 2 plus 2. 4 and then 5 and 6, right? But how can we write this case into our coding using some mathematical formulas? So if there is a strict case, that is, if the number of bananas is exactly divisible by your s value, right? Then in that case we just take the divisible, the quotient, that is x by m, that is here 20 by 10 is equals to 2. But the cases where the number is not strictly divisible, that is this 15, right? This 15 is not exactly divisible by 10. So 15 by 10, which will give you 1, right? That means in the first hour, she consumes the first 10 bananas, right? But she will need one additional hour to consume the 5 bananas, the remaining 5 bananas, right? So that is why in this mathematical formula, we will be taking x by m plus 1, right? Hope that makes sense. So there goes our entire code. But what would be the time and space for this method one? O of n square, because we are using this for loop, and there is one nested for loop, that is helper function, which is itself is iterating into the pile of bananas, that is into the array, right? So I would say O of n square, or basically you can say n cross m, where m is nothing but the maximum of array of I, right? And what would be your space complexity? O of 1, because we are not using any space instead of just few variables, right? Let us see the code in action, then we'll move ahead with the optimized one. Okay, so here goes our method one approach, and definitely it should pass for all the cases, for most of the cases, but we'll get the TLE for rest of them. Why is it happening? If we analyze the constraint, right? So array of I is going to 10 power 6, right? That means the maximum range for an element that is present in this array is 10 power 6, right? So say for assume that the maximum value in this array would be 10 power 6 and size is also 10 power 6, right? So so basically the number of iterations which we have used is nothing but n is pointing to 10 power 6, m is pointing to 10 power 6. If you do the whole square of it, it will be 10 power 12, which is greater than my 10 power 8 iterations. And if we need to compile, if we need if we want a successful submission, then definitely the number of iterations should be less than equals to 10 power 8. Now, where this 10 power 8 is coming, how the constraint analysis is going on. So you need to watch one more video, that is trick the TLE by Akshay, and you will get the ins and out of how to analyze the constraint and how to approach a question with a definite algorithm upon doing a constraint analysis. Okay, so moving ahead with the optimized one now. So do how are we gonna approach with the second approach? Mm, okay, so here we will use the binary search format, right? So binary search कैसे लगाओगे यार? In binary search, the prerequisite is that you should have a sorted array, right? A sequence of sorted numbers where you can apply the binary search. So what this algorithm says is basically, so let's say you have a number that is going from L to high, and this is sorted, so definitely sorted. So 1, 2, 3, 4, 5, 6, and then something like this. A sequence of number which is in either ascending or descendingly sorted, right? So what this algorithm says is that we found a midpoint, right? So 10 plus 1, whatever this says, 11, 11 by 2 is nothing but 5, right? So the midpoint of this range is 5, right? So based on some certain conditions, right? Based on some certain conditions, which we will derive in this video moving ahead, we neglect one of its half, right? So assuming we neglected the right half, right? So when I say neglecting, it means that we will not iterate, or we will not even check for the values present in this from 5 to 10, because upon that certain condition has make sure of that, right? So now my only iteration, or the bound iteration where I need to check my possible answer, is the left half, right? And this left half also will again find a midpoint, and will again check that my left half or right half will give the probable answer or not, right? If you will see, the numbers are decreasing from n to n by 2, n to n by 2 to n by 4, and to n by 8, till we are getting a probable answer, or let's say the possible answer, right? And this range is nothing but represented by log n in the mathematical world, right? And since we are decreasing the number by 2, right? So log n base 2. If n would have been decreased by n by 10 and then n by 100, right? Then this would have been written as log n base 10, right? And that is why the time complexity of this binary search is log n. So there was a point one. Now, point number two, in which range we need to apply the binary search. Now, coming back to our brute force technique, if you will see, that we applied the for loop from I equals to 1 to less than equals to high, right? And this is my range basically where I need to apply my binary search, right? So I'm gonna apply a binary search that is start from 1 till the high, that is the maximum element in this array. And we're gonna dry run the specific case, that is the second test case, that is which have elements as 5, 10, 15, 20, and k is equals to 7, right? Minimum value is 1. The maximum value in this array is what? 20, right? So what would be the midpoint? Midpoint would be minimum value is not okay, yeah, 1. The minimum value is basically 5 in this array, but the question, but it can be, हम ऐसा कह सकते हैं कि that s value in which the player is bound to choose one s value, that is the minimum number of bananas, it can start from 1, right? It may not start from the lowest value from this given array, right? 1 भी तो एक possible answer है, so uh, we need to take that into account as well, right? So this would be L, this would be high, and what would be your midpoint? So 20, 20 plus 1, 21, 21 by 2, which will give you what? 21 by 2, which will give you 10, right? Hmm. So now our helper function will work, and it will give me the count or the number of hours needed to complete the pile, or the player can eat the whole pile present in this array of I if she chooses as s equals to 10, right? That is, the number of bananas can be eaten per hour is 10, right? And again, the elements are 5, 10, 15, and 20. So the number of hours needed to eat this pile would be 1. This pile again 1, because at each hour or within an hour, the player can eat 10 bananas, right? So this will again require 2 hours, and this strictly 2. So this is nothing but 2 plus 2, 4, 5, and 6, right? And our given k is 7, right? So this is less than equals to 7. Now you tell me what shall we do? Which half to ignore? Definitely, we should ignore the right half, because in this case, I can see that upon taking or upon eating 10 bananas an hour, I'm getting a value 6, right? Which is lesser than my total given number of hours to me, right? That means if I even increase, if I even decrease the number of bananas per hour, I may get an answer. I may get an answer, or let's say I may get an answer, or there's a total number of hours that may be equals to less than equals to 7, right? ऐसा मैं क्यों बोल रहा हूँ यार? देखो, मैं 10 बनाना एक आवर में खा सकता हूँ और मेरे को टोटल नंबर ऑफ आवर्स लगे 6, राइट? तो हो सकता है कि अगर मैं और कम बनाना खाऊं, लाइक 9 बनानास पर आवर खाऊं, तो हो सकता है जो नंबर ऑफ आवर्स है वो फिर भी 7 से लेस ही हो। ऐसा मैं क्यों बोल रहा हूँ? उल्टा सोचो, अगर बनानास मैं बढ़ा दूं, 10 से 20 कर दूं, लेट्स से, राइट, बढ़ा दूं बनाना, सो डेफिनेटली 6 से जो 6 घंटे 6 आवर्स लग रहे, उससे तो ज्यादा ही लगेगा, राइट? तो हम इसके लिए चेक करेंगे, सो वी गोना चेक इट फॉर डिक्रीजिंग द वैल्यू, right? And decreasing the value, that means we're going to ignore the right half, right? So our L would be updated to m plus 1. तो मेरे को राइट हाफ इग्नोर करना है, मतलब ये हाफ इग्नोर करना है, तो मतलब इस हाफ में मेरे को करना है, तो दैट मीन्स हाई इज इक्वल्स टू मिड, राइट? मैं ये कह सकता हूँ, राइट? सो my pseudo code will look like this, that if helper of array comma mid is less than equals to k, then I'm going to ignore the right half. So I'm going to iterate in which half? The left half, that is high, would be pointing to mid, right? So my new low is again remain same, and my new high, my this low, and my new high would be pointing to mid, that is 10. Now my new mid would be equals to 10 plus 11 by 2, which is equals to 5, right? Now what will happen? At 1 hour mein, in 1 hour, I can eat 5 bananas, right? So I'm going to calculate for this s equals to 5, right? And again, the values are 5, 10, 15, and 20. So for eating this pile, I need to take 1 hour. Eating 10, I need to take 2 hour. 15, 3 hour. 20, I will take 4 hour, because each hour I can only eat, or the player can only eat 5 bananas, right? So what is the total number of hours? 4, 3, 7, 2, 9, and 10, right? So this 10 is definitely greater than k, right? So here हमें answer तो नहीं मिला. That means कि हमें number of bananas को increase करना पड़ेगा to fit in this equality. That is, this number of I should be less than equals to k, right? So I'm gonna say increase the value. Increase the value, right? So increasing the value means there's a number line, right? I'm here low, high, and mid. Increasing the value means I need to iterate in a higher range. That means I will neglect the lower range, right? So in this case, I will write an else case. Else case, I'm gonna say that low is equals to mid plus one. We're gonna use the same pseudocode into our actual code, and we will see the code in action in some time. So my next iteration. So let's complete the iteration first. So my new low would be pointing to mid plus one. That is, mid was 5, so it would be 6. And my new high would be pointing to the same high, that is 10. Right now, again, the new mid would be 10 plus 6, 8, 10 plus 6, 16 by 2, which is 8. Right now, for S is equals to 8, what would be the total number of hours? So for consuming this pile, which has the 5 bananas, at each hour I can eat, at in 1 hour I can eat 8 bananas. So 1 plus 2 plus 15, right? So I'm gonna need 2 hours. 2 plus 20, so I'm gonna need 3 hours, right? So this is nothing but 3 to 5, 7, and 8. So it is still greater than my k value, right? So I'm gonna again increase my value. Increase value, right? So now my new low would be again mid plus one, that is 9, and my high remains same, right? So let me zoom in a bit. Okay, so my mid is nothing but 19 by 2, which is nothing but 8, right? And for 8, uh, 19 by 2, so 2 9 so 18, right? So it would be 9. So for S is equals to 9, the time consumed would be again 1 plus 2 plus 2 plus 3, which is nothing but 8, which is again greater than k. So I'm going to increase the value again. So increase value again, right? Don't mind my handwriting, just follow my voice and write it along, write it along on your paper. Again, so my new low is nothing but 10 and my high remains same. Now you can see that we have low and high equals to the same value, right? And if you find a mid, it would be again equals to 10. But if you will see, this 10 was already calculated in the past, that is in the first iteration itself. In the first iteration itself, is it? Yep, in the first iteration itself. So तो बाइनरी कंडीशन को स्टॉप करने के लिए यार एक कंडीशन लगती है while जो हमारा लो है लेस देन हाई हो जाए मतलब कि we have a range that is low and high when the two of the values crosses each other. That means there is no point of doing the iteration again and again. I'm like, there's no point of doing the iteration again, right? Because the range itself has crossed each other. So while less than equals to high, this would be our terminating conditions for our binary search. And uh, I hope I did all the dry runs and it make complete sense now. Let us look at the final code. So this is our final code, right? So int low and high is declared. There is a for loop that is calculating the low and high, right? And what else? So this line itself is not required now. While I was first attempting the problem, I actually initialized my low with the lowest value in the array. But then I realized that no, in this question we can at least there is a possibility that s can be equals to one, right? And one may not be present into our array of I, and that low will never point to one using this line, right? तो मिनिमम वैल्यू वन भी हो सकता है इसलिए हमने यहाँ पे लो रखा है तो इस लाइन को हटाया जा सकता है and high would be there to track the maximum element in the given array. Now there's the termination condition of the binary search, and here the binary search starts, right? So mid is equals to low plus high by 2, right? And to avoid overflow, you can use some another condition as well. There is low plus high by 2, right? So you can do plus L minus L here in the numerator, and you can separate some things, right? So it would be high minus L by 2, clubbing these two and 2L by 2, that is L, right? So this will avoid some overflow because instead of summing two big numbers, in case low and high are big numbers, then we get an integer overflow. Instead of summing two big numbers, we are first subtracting it, dividing by two, and then summing with some big number, right? So this decreases the chance of overflow. So just a handy technique you can implement in your questions or in the computer programming. So again, calling the helper function, right? And if that is the case, that is less than equals to k, as we discussed, high would be pointing to mid, that is neglecting the right half, else low equals to mid plus 1, right? And this would be specifically be the case where our low is equals to high. In that case, we saw that returning low or high would give an answer, right? So yep, एंड देयर इज वन मोर टेक्निक एज वेल. मैंने यहाँ लो रिटर्न किया है, बट अगर आप यहाँ पे एक अलग से आंसर वेरिएबल बनाना चाहते हो तो यू कैन डू दैट एज वेल, राइट? उस केस में आपको कोड थोड़ा सा ट्वीक करना पड़ेगा. दैट इज यू नीड टू राइट व्हाइल लो लेस देन इक्वल्स टू हाई, right? And here you need to store your answer. So here would be you will be saying answer is equals to mid, right? And you need to update your high as mid minus one. If you take down that path, because in the dry run I showed that whenever there was a possibility of less than equals to k, we tracked that particular s, right? We tracked that particular s, and then we iterated in hope that we can get an even a minimum value, even a lower value of this particular s, right? So there are many ways to write a code, and I explained both of them to you. So feel free to try this in your code editor, and it would be good. So what would be the time and space for this one? O of n. This binary search will take log n, right? So O of log n, and this n would be nothing but the maximum of array of I, right? Star n, I would say. That is the number of elements in array, because this helper function is running inside our binary search. So O of log n and log n as your time, and space as O of 1, right? Let us see the code in action, and we will stop this video then. Okay, so there goes our pretty and successful submission. And we have solved today's problem. So kudos to every one of you who has solved it. Kudos to myself as well. And this question marks our day of 627 of publicly solving problem solving. And few last thing, that this is my Discord channel where I uh, post the daily updates, and you can follow it along to have a regular update on that. Now, that's a DSA repository where I push all my source code, and it consists of, I don't know, more than 500 plus standard problems. You can start and fork to get help with your interviews and other things, right? So, so with this good note, let us stop this video, and we'll meet again in the next one. Till then, keep learning, keep growing. Bye bye, and take care.